All right. Um, the clock has now struck 12:30, and I am trying very hard to keep it together because it is very rare that you get to introduce one of your academic heroes. This afternoon we have Professor Richard Mayer coming to talk to us, and as you'll see from the chat, his reputation precedes him for very good reason. Professor Mayer is a distinguished professor of psychological and brain sciences at the University of California, Santa Barbara. His research interests involved applying the science of learning to education. His current research is at the intersection of cognition, instruction, and technology, with a special focus on multimedia learning, game-based learning, learning in virtual reality, and learning with animated pedagogical agents. He has served as the president of Division 15, which is educational psychology of the American Psychological Association, and vice president of the American Educational Research Association for Division C, learning and instruction. In terms of awards, he has received the E.L. Thorndike Award for Career Achievement in Educational Psychology, the Scribner Award for Outstanding Research in Learning and Instruction, the Jonasson Award for Excellence in Research in the Field of Instructional Design and Technology, the James McKeenan Cattell Award for a Lifetime of Outstanding Contributions to Applied Psychological Research, the American Psychological Association's Distinguished Contribution of Applications of Psychology to Education and Training Award, and the Citizen Psychologist Citation for 4 decades of service as a local school board member. He's been recognized in contemporary educational psychology as the most productive educational psychologist in the world. And he's amongst the top 0.1% of the world scientists in terms of citations. My own research, this is all reflected in Professor Mayer having over 250,000 citations to his works, 270,853 to be precise. He has 612 articles that have 10 or more citations and 193 articles with 193 or more citations. What is even more astounding is that just in the past 5 years, more than a third of the citations have come from the last 5 years. If we look at those articles with 10 or more citations, 63% of those have come from the last 5 years. And if you look at those 193 articles with 193 or more citations, 70% of those have come in the last 5 years. So Professor Mayer's trajectory is just ramping up. He serves on the editorial boards of 12 journals, mainly in educational psychology. He's the author and co-author of more than 600 publications, including 35 books, such as the Multimedia Learning, 3rd edition, e-learning, and the Science of Instruction, 5th edition, and the Cambridge Book of Multimedia Learning, 3rd edition, and several others. And so it gives me absolute pleasure and a fair amount of humble excitement to introduce to you Dr. Richard Mayer, who's going to be talking to us today about teaching with instructional video.
Oh my gosh. Thank you so much, Simon, for that lovely introduction. Can everyone hear me okay? Okay, great.
Perfect.
That was so kind. I only wish my dean could have heard it, but but I do appreciate it. It's really an honor for me to share some of our thoughts and research on teaching with instructional video today. Um, Let me just give you greetings from University of California, Santa Barbara. This is our campus, so just to mention, we're on the beach. Just want to make that clear. Um, what I want to first do today is just give you an introduction to this whole field. I see this research as an attempt to apply the science of learning to education. This is kind of one facet of it. I want to spend just a little bit of time looking at how meaningful learning works. Um, and then I want to spend more time looking at evidence-based principles for how we can design effective instructional video. So first, my general domain, my basic focus in life really is or at least academic life, is applying the science of learning to education. Oh, and I should mention, I guess we've agreed, I'll talk for a while and then at the end we'll have time for questions. If there's some like um, procedural thing you want to bring up, you can put it in the chat and Simon can tell me, I guess. Um, so what I mean by the applying the science of learning, in order to do that, we really have to look at three issues. One is how do people learn? Um, so that's the science of learning. How to help people learn, which I would call the science of instruction. And along with that, we need to be able to determine what people have learned. So that's the science of assessment. So these all kind of interact in my research program, um, which has been going on for many, many decades. Um, and these books on the left are more about how people learn, and then the ones in the middle are, I guess, science of instruction. The one on the right, revision of Bloom's taxonomy, is more about assessment. Um, my talk today really is coming from a forthcoming book. This is almost out there. So it even has its cover, Teaching with Instructional Video. It's kind of in its final stages. Hopefully, we'll see it in the next few months. Um, so let me just start. If we're looking at instructional video, um, one of the places we can start is just to look at a quote from Thomas Edison, who says that uh, uh, motion pictures will replace textbooks within the next 10 years. Our whole school system will be completely changed. This is from an interview in 1913, but there are many quotes from Edison kind of saying the same thing. And so what that tells me is um, even more than 100 years ago, we knew that there was something really exceptional about instructional video and its potential for education. But as we all know, we have not really fulfilled Edison's dream yet. And kind of the research I want to talk about today is trying to take a scientific approach to how could we design instructional video so that it actually could have a better role in education. Um, so first, I want to look at how meaningful learning works, and I'm just kind of summarizing. So my idea here is that three cognitive processes have to occur for meaningful learning to take place in the learner's head, learner's cognitive system. You have to select the relevant information from the lesson, which is a very difficult step for many learners. You have to mentally organize that information into a coherent structure that makes sense to you. And then you have to integrate that with incoming information. Um, you have to integrate this incoming information with your relevant prior knowledge that you've activated from long-term memory. Um, my work kind of draws from three principles from the learning sciences. One is the idea of dual channels, which is that people have separate channels for processing verbal and visual material. Limited capacity, which is probably the number one contribution of cognitive science to the world, but actually William James said it way before cognitive scientists did, that we can only process small amounts of material in any one channel at any time. Um, and active processing, kind of in contrast to that, in order for us to engage in meaningful learning, like I just said, we have to be able to mentally, we have to attend to the relevant material, organize it into a coherent structure, and integrate it with our relevant prior knowledge. So the challenge for instructional designers is we're working with a system that has very limited capacity. It has these two channels, um, but we have to prime an appropriate processing in that limited capacity we have. This is my graphic representation of how learning works. Um, a lesson comes in, for some reason, flowcharts, things always start on the left. So the lesson comes in on the left, the multimedia presentation, let's say. It enters our ears if the words are spoken, our eyes if the words are printed, the pictures enter through our eyes. If we attend to some of that fleeting information, um, we can get it into our working memory where we can mentally organize the verbal material into a verbal model, the visual material into a pictorial model. Then we can integrate those models with each other and also with relevant prior knowledge activated from long-term memory. So the boxes are the memory stores and the arrows are the cognitive processes. Hope this makes sense. If it doesn't, please ask me. Um, so that's my 2 minute summary of how learning works. Kind of covered 100 plus years of serious thought in 2 minutes. So I might have left a few things out. Um, how does instruction work? Our problem is, like I said, we have a limited capacity system, but there are three basic demands on that system. Extraneous processing, which is kind of wasted cognitive processing that is not in line with the instructional objective. And that's just caused by poor design. Um, Essential processing, this is cognitive processing to get the presented information into our working memory so that we can work on it. Um, and that really depends on the complexity of the material for the learner. If it's complicated, it's going to require much more essential processing. Lastly, is generative processing. This is the cognitive processing required to make sense of the presented material, and this really depends on the learner's motivation to exert effort. And that's kind of the newer line of research that I want to emphasize more in today's talk. So, three top level goals for instruction are to reduce extraneous processing, since that's taking away from the available processing capacity we have. Manage the essential processing so that it's not overwhelming to the learner, and then also foster this generative processing if learners aren't initially predisposed to work hard to understand. Um, Lastly, I'm going to look at the science of assessment for a second here. Um, yeah, two kind of classic ways of measuring learning outcomes are tests of retention, which really just look at um, how well students learned the presented material, and tests of transfer, which attempt to measure understanding, how well can this learner apply what they've learned in a new situation. All the studies I'm going to talk about today focus on transfer as the dependent measure because I think that is the most relevant for education. Let me just give you a quick example. Here's just a very brief explanation of how a bicycle tire pump works. So a voice could be, a narrator could be explaining this to us, um, let's say on a computer or on a podcast. Um, it kind of summarizes how it works, but most people get pretty much nothing out of this. They don't perform very well on a transfer test. However, if we embed that material in an animation, so we have the exact same narration, but now we have an animation that kind of visually shows what the words are talking about in sync with what the words are talking about. My idea is people will understand um, the explanation a little better. So the kind of tests we can give a retention test where we ask people to write down what they can remember, or a transfer test where we ask people, could you redesign this to be more effective? A troubleshooting question like, uh, if it's not working, what could be wrong? Or a conceptual question like, why does the air enter the pump or exit? Where you have to kind of invent the idea of air pressure. Um, just to give you an overview of um, some of our initial work, um, we tried in 9 different studies to compare lessons that had words and pictures versus just words alone. So, for example, just the narration versus the narration with the animation. The black bars are the multimedia versions of the lesson, the white bars are words only. And on the y-axis, this is the percent correct on a transfer test. And you can see on a transfer test, people are doing much better if we add animation or graphics to words. So I call this the multimedia principle, that people learn better from words and pictures than words alone. This is kind of what got me started in this whole field like 3 decades or so ago. Um, these are 9 different tests with different materials that I'm just summarizing here on this. So I'm pretty certain that there is evidence for this idea. It doesn't mean the problem is it doesn't happen all the time. Not all multimedia presentations are helpful. Not all graphics are helpful. So we need to understand how should we design the graphics, especially in a video, to maximize transfer. So I'm really focusing here on effect size because I think that is the most important when we do instructional intervention studies. We want to know how powerful was the effect. So if we add something to a video, how much does that improve people's performance on a transfer test? Even if it's statistically significant, if the effect size is small, that's not so educationally important. So I'm really focused on studies that create or on techniques that can foster an effect size of at least zero point 0.4. So we want to improve learning by zero point 0.4 standard deviations on a transfer test. This is a kind of an outline of a typical study. Um, we have one group, which I'll call the base group, that studies just the regular version of a video, and another group that gets the exact same video but with one feature added. So maybe in the base version, we have the instructor standing next to slides as she explains them. In the enhanced group, maybe we have the same instructor, but this time she's smiling, she has outward gestures, she tries to be a lot more positive. So we want to see, does having a more positive instructor affect learning? So then we have the learners take a transfer test. We look at the means and standard deviations, and from that we can compute an effect size. And like I said, we're looking for effect sizes that are at least zero point 0.4 because that's kind of the benchmark that Hattie and others have kind of laid out there as being educationally important. Is this making sense to everybody so far? I'm on board? Okay, great. So let me now go on to kind of covered in a very short time my lifetime of thought on this, but that's okay. Um, Now I want to just kind of share with you what I'm calling evidence-based principles for designing effective instructional video. Um, and the reason I kind of got interested in video is not only from what Edison said, but also because I think it is an available technology that's inexpensive to create and really has potential to have a strong impact on learning. It's not quite as cutting edge as some other things we could look at, like virtual reality or even game-based learning, but I think it really has potential. So that's why I wanted to kind of look at it today. Um, so we've conducted hundreds of studies where we compared the learning outcomes and processes of students who receive a base version of our lesson, so the base version of a video, versus the same video with one feature added. And today I want to share with you 14 evidence-based principles that I'm pretty sure of that we can create in a lab. Whether they work in the real world, um, we need more research on, but at least I can share with you we can what we can do in our lab. Um, so first, let me look at techniques for fostering generative processing because I think this is the newest area. This is the least investigated so far, kind of the most fun in some ways. What we're trying to do here is let's say we've created a really good video that we think meets all of the criteria of effective video, but people still aren't learning that much from it because they're not engaged. So how do we get people, um, if they have the capacity available, how do we get them to use their cognitive capacity to work hard to make sense out of a lesson? So these are 6 techniques that I think have potential. So first is personalization. This is we can take a lesson like the one on the left, um, which is has formal wording. This is from like a lesson on the human respiratory system. We took books from the that were approved for use in California public schools, and of the 9 books that we had, 2 of them actually were totally incorrect in the way they explained it, which is really depressing, but that was not our focus. Um, so here's like a video. You can see from the screenshot, we're not great artists, but it says during inhaling, the diaphragm moves down, creating more space for the lungs. So that's what the narrator is saying. It didn't have red font. I'm just putting that there to emphasize it. The version on the right has conversational wording, and in this case, all we did was change the to your. So during inhaling, your diaphragm moves down, creating more space for your lung. So all we're doing here is changing the wording from formal to conversational. In 13 out of 15 experiments that we ran, we're getting a very strong effect of converting the wording from um, formal to conversational with a median effect size of 1. So transfer test performance increases by 1 standard deviation, which is a very impressive, a large effect. Um, One thing we found in some of our studies is that this might not apply to higher achieving learners. They might not need this, but for beginners, for sure, this has an effect. I really didn't believe this finding when one of my grad students found it. Um, and I asked her to replicate it 3 or 4 or 5 times before we published it. But it certainly comes back when we do replicate it. Um, Next is, so that's a very simple thing to do to improve performance, as a student learning on a transfer test. We're not really changing the content. We're just using more conversational wording. In that case, we're kind of priming self-reference. So maybe it's drawing the learner in a little bit more about your lungs. And maybe that motivates you to engage more. Okay. Embodiment principle. So embodiment theory is kind of a little bit out there sometimes, but it's the idea that we learn and we teach with our whole body. You can think of an instructional video as a communication message. It's a message, and part of that message is the visual part. Part of it is the words that are but part of it is the instructor's body. Um, so here's a lesson demonstrating how to build an electrical circuit. The version on the left um, is filmed from a third-person perspective, kind of like YouTube videos usually are. It's kind of the typical way to do it. The version on the right is filmed from a first-person perspective with the camera kind of over the learner's shoulder. It's the exact same instructor, same words, the same episode. We just had 2 different cameras. Um, and the idea is that the version on the right, you might feel more like it's your hands that are creating it. So you might feel more engaged, more self-referenced. Um, Another kind of form of embodiment is um, we could have a lecturer. So in this case, Celeste is explaining the Doppler effect using um, illustrations that are already on the whiteboard. So she just kind of can refer to them. And the version on the right, she has the exact same script, the exact same instructor, but she's drawing the illustrations as she's lecturing. It's a more embodied situation. You might feel like it's your hand that is creating those drawings. That's the idea. Just one other version of embodiment. On the left, we have an instructor explaining how the kidneys work. She never makes eye contact. She's always looking at the board or to the side, but no eye contact with the audience. The version on the right, this is using what's called a transparent whiteboard. She can look at you. You can see her hand drawing as she's talking. So the idea is she's more engaging because you kind of contact with her. Um, in 16 out of 17 experimental tests using techniques like those, we get a median effect size of 0.58, meaning that implementing those kinds of changes using first person instead of third person, for example, result in better performance on a transfer test. Um, so now we have two ways maybe of encouraging the voice principle is pretty straightforward. It's the idea that the instructor's voice should be appealing to the learner. Um, so in the version on the left, we have a lesson on how lightning storms develop. It's a narrated animation that lasts about 2.5 minutes. Um, we have one version where the speaker kind of has a bored kind of voice, not very excited. Um, so not that appealing. The version on the right, the speaker has more like a announcer's kind of voice, like a disc jockey's kind of voice, a lot more enthusiastic. Um, People learn better from the appealing voice than the unappealing voice. In 5 out of 6 studies that we ran, we're getting a median effect size of 0.74. And these studies, mostly we were comparing a human voice to a machine synthesized voice using some of the older simulators. Maybe today's simulators um, would overcome that problem. Um, but at least that's telling us there's something about having a pleasant voice that encourages people to try harder. Positivity principle, it's a similar idea, but it has to do with the whole body of the instructor. So on the left, we have a lesson on a statistical concept, binomial probability, where we actually hired a student in our university's theater department. She's fantastic. She gave the same lecture um, with a negative stance, so with kind of a frustrated or bored voice, a very not very friendly facial expression, her hands kind of crossed against her body, so all conveying negative affect. The version on the right, has positive facial expression. She smiles. She has a more positive voice. She uses outward gestures. Um, she has the exact same script, the exact same slides, the same pacing, but people learn better from the lesson when we have a positive instructor. Um, so in and this is using different kinds of materials in 3 out of 4 studies. So we're just starting to understand how this works, and we're not getting a huge effect size yet, just 0.34. But I think this is a promising idea, and it kind of makes me want to smile when I lecture to my students in my courses. Um, Emotional design. It's kind of a similar idea that we want to induce positive affect, but in a slightly different way. Um, this involves using kind of converting the elements in a lesson from it's kind of standard way of presenting it. So on the left, we have a lesson on how a virus causes a cold. And there are 5 or 6 steps that we go through. Version on the right, we've the virus and the host cell um, into figures with appealing colors that have been tested to evoke positive affect. We give them facial expressions that are consistent with the storyline. So the virus has fierce facial expression, and the poor host cell looks kind of clueless about what's happening to it. So the idea here is that this creates a more positive affect in the learner. They kind of want to focus more on what's going on in this lesson with these characters that have facial expressions. Another version of this is to take the lesson on how lightning storms develop that I mentioned before, which is just in black and white drawings, and convert it to color animation using characters from the Disney movie Frozen that are kind of in sync with what the lesson is talking about. And what we find is in 4 out of 4 studies that we've been able to do so far, we get a median effect size of 0.57. So people perform better on a transfer test when the key elements in the graphic are rendered with facial expressions and warm colors. So that's just a way of trying to evoke more positive affect in learners. And lastly, generative learning, generative activity principle. This is the idea that people might be pretty passive when they're viewing a video. You just sit there and you're not really doing anything. So to get them to get more physically engaged, we can stop the video every once in a while and ask them to do something like, please type in a sentence that explains what you just learned. So in this lesson that I'm showing on the left, this is a lesson on greenhouse gases. It has 4 segments to it. And we stop the lesson after each segment. We ask the learner to type in just a sentence that explains what they just learned, and then it goes on to the next segment. Um, that's the version on the right. So all we're doing is taking the lesson from the left and just adding these prompts to self-explain at 4 points in the lesson. We're not giving any feedback. We're not providing any more information. We're just trying to get the learner to be a little more engaged. Um, when we ask learners to carry out generative learning activities during pauses in a lesson, like the one I just showed you, in 37 out of 44 tests that we've run, we get a median effect size of 0.71. So that's a reasonably large effect size for incorporating generative activities. So what we have, what we have so far is 6 techniques for trying to promote generative processing, trying to get the learner more engaged. So I think we have the beginning of a good arsenal of tools we can use to try and motivate students to try harder. Um, Next, let me look at kind of the more classic research on uh, techniques to improve instructional design, because the original studies in the field of multimedia learning kind of focused on this issue of how can we reduce extraneous processing? How can we get students to focus on the important material, not the irrelevant material? Um, so this is kind of like the um, kind of one of the first steps in instructional design. One very straightforward thing to do is I call the coherence principle. This just means let's weed out irrelevant material. Any material that's not supporting the instructional objective, we don't want in the lesson. So on the left, we have a version that contains what people call seductive details. So this is from, again, from the lesson on how a virus causes a cold. And we found these facts about viruses. We tested our our students at UCSB, and with I think we had about 60 facts. This was their number one most interesting fact, according to our students. A study conducted in Pennsylvania reveals that people who make love once or twice a week are more immune to colds than folks who abstain. So that you could put that in because maybe it makes it all more interesting and people will pay more attention because there's something interesting in there. The version on the right, we take out the seductive detail because consistent with the coherence principle, we want to take out anything that's not directly relevant. What we find is people do much better when we take out the extraneous material. So having that interesting but irrelevant fact hurts learning. In 18 out of 19 tests, we get a median effect size of 0.86. So that's why I'm trying not to have anything interesting in this talk. No, only kidding. Um, so that's kind of one of the number one rules of instructional design that we're all taught. Like, keep it simple. Don't put in more than you need. Um, the second way of dealing with this is if we can't weed out the irrelevant material, at least we can highlight the important material. So that's what signaling does. So this is an example from a study on how neural transmission works. It's in Chinese, so I'm not good at translating this for us, but it's with colleagues in China. Um, and what it version on the left, the instructor is just standing there. She never points to anything as she explains the slides. The version on the right, she's pointing to what she's talking about and as she's speaking about it. So she's signaling where to look on the slide. Um, when we highlight where to look on the graphic as the voice is talking about it, that improves learning in 26 out of 28 experiments that we ran, and with a median effect size of 0.70 on transfer tests. So both coherence and signaling are ways to get people to pay attention to the important material. Redundancy, mm, you might be tempted if you have a narrated animation like this one on the left that explains how lightning storms develop. You might be tempted to add on-screen text to maybe help learners who rather read than listen, so they can make their choice. But the version on the right creates what's called split attention. If you're reading the caption, you can't be looking at the animation. So you might miss something that's going on. And also having two different sources of the same words might cause people to try and reconcile those two streams, which also wastes processing. So what we find is adding on-screen captions to a narrated animation or narrated video doesn't help learning. It might help in certain situations, like if you're learning in a second language, or if there are a lot of technical terms, or if we use very shortened text. Those all, in those cases, having the on-screen captions helps. Spatial contiguity. This is just saying if we have words on the screen and graphics on the screen, like we do on the left, it's typical to put the words at the bottom as a caption. But that again creates a lot of problems because the learner has to scan back and forth between the words in the caption and where to look in the illustration or the video. On the right, what we've done is taken the text and just embedded it in the illustration next to the part of the illustration it's talking about. So this is an explanation of how cars' braking system works. People do much better on a transfer test if they get the version on the right than the one on the left. And we've done this with various lessons, including the lightning lesson, which I've shown you before. In 9 out of 9 experiments, we get a median effect size of 0.82, showing that people learn better perform better on transfer tests when corresponding words and graphics are near each other on the screen rather than far apart. And lastly, temporal contiguity, or I might call it synchrony. The idea is on the version on the left, we have successive presentation. So we could have a video of the lightning storm, of how lightning storms develop, and then the narration of it, or vice versa. So you get really a double exposure to the material. You might think that would be better, but the version on the right is much more effective, where we have simultaneous presentation of the animation with the corresponding narration. So people do much better when corresponding graphics and narration are presented in sync with each other in 8 out of 8 experiments with an effect size greater than 1. So these are all techniques for reducing extraneous processing, helping people have the resources they need to make sense out of the material. Let me go on to the last set of techniques. These are techniques for managing essential processing. So if we've cleaned up the lesson and we've applied some of the instructional design principles that allow people to, we'll say, kind of focus in on the important material and get that into their working memory. That's a first step. But sometimes the material itself is just very complicated for a learner. If you're an expert, it might not be overwhelming, but if you're a beginner, the same material could be overwhelming. So it may overwhelm your processing system. You may not have enough cognitive capacity to take in all the material that's being presented. So we need ways of managing the flow of that information. One technique is segmenting, which means breaking the lesson into parts and then presenting them progressively, starting with one aspect of it, then adding the next, then adding the next, rather than presenting everything at once. So, for example, going back to this narrated animation on how lightning storms develop, it runs for about 2.5 minutes, the way we originally designed it. It has 16 major steps in it, so it's complicated. And if you kind of lose one of those steps, then the whole rest of it might not make sense to you. So this could be overwhelming for learners, the amount of information presented in fast-paced video. So one thing we can do on the right is to stop the video um, after each major step. So the first step is cool, moist air moves over a warmer surface and becomes heated. Then it can stop, and you click on continue to go on to the next segment. So all this is doing is presenting the lesson segment by segment. It's not adding any information. It's just giving the learner control over the pace of the presentation, and it's stopping the lesson at the conceptual boundaries. So just kind of step by step. Doing something as simple as adding this little continue button at major, you know, points in the lesson greatly improves people's ability to transfer what they've learned from the lesson. Another way of doing this that we're kind of all familiar with is in a PowerPoint presentation. We can present all the material at once. So on the left, this is from a lesson in a geography course on geographic information systems. It's pretty dense, pretty complicated, but this is the slide that the instructor actually used. Um, but we could present it part by part. So on the right, we show first the upper third, then we add the middle third, then we add the bottom third. This is just a way of making sure you digest one part before we move on to the next one, so it's a little less overwhelming. Um, what we find in 7 out of 7 experiments that we ran, that presenting the material in learner-paced segments results in better learning than presenting it as a continuous unit with an effect size of 0.67 on a transfer test. So segmenting is one way of just managing a really complex lesson. Another way is through pre-training. If we're going to, for example, try to explain how cars' braking system works, we can show people a video um, with the screenshot on the left is from that video. It starts out when the driver steps on the brake pedal, and then it goes on from there. The problem is it contains a lot of jargon terms like piston in the master cylinder or brake drum, brake shoe. People might not know what those components are. So that will increase your cognitive load if you're trying to figure out what do these terms mean. Well, the video is trying to explain the cause and effect system. So to kind of offload some of that complexity, we can give people practice with the terms so they know what the terms mean before they watch the video. So on the right, we show that we give a little pre-training where you can click on any part of the system, like the piston in the master cylinder. Then that part is highlighted. You see the piston moving forward and back, and it says this is the piston, it can move forward or back. So you get to know what the terms mean, what they can do. That's building what people call component models for learners. Then when they're given the video, they can build a cause and effect model of how a braking system works. And what we find is in 10 out of 10 experiments, providing some kind of pre-training helps people learn better from a narrated animation. We want people to kind of be familiar with the names and characteristics of the main concepts. And lastly, the modality principle, the most studied and controversial principle. This is the idea that if we have a video or narrated animation, it's better, or we'll say an animation, it's better for the words to be spoken than for the words to be printed. So on the left, we have the words are presented as narration. On the right, as on-screen text. The problem with the version on the right, which I've already alluded to, is it creates split attention. If you're reading those words, you can't be looking at the animation. If you're looking at the animation, you can't be reading the words. This goes by pretty fast, so you might miss something. The version on the left allows us to offload the words onto the verbal channel. The animation can come in through the visual channel, so we've effectively increased people's processing capacity, if that makes sense. So in 18 out of 19 experiments that we've run, people learn better from graphics and narration rather than graphics and on-screen text with a median effect size of 1. Although some of the boundary conditions are it might not apply when the words are familiar or in your second language, or if the lesson is very slow paced or controlled by the learner. So I've tried to cover these 14 principles in a short amount of time. I'm glad to answer your questions. These are some of the research team who, made this all happen. They happen to be standing in my backyard here. And these are some other resources for you. So I'm now glad to answer any questions you have.
Thank you very, very much for that. You did phenomenally well going through 4 decades of research in our very stringent 45 minutes. What I really admire about this is that a lot of these are very clean experiments. It's, as you say, taking one of these things and manipulating it. And then the broader context of the symposium where we're trying to use H5P, I can see a lot of stuff for generative, for advancing things one-on-one. H5P is well suited to take a lot of these principles and embody them. While I am absolutely happy to open up to questions, while people write down their questions, I would like to get I've got a couple, but I'll stick to one for now. When we think about sort of the cognitive science of learning with things like retrieval practice, spaced learning, and feedback, we can see, and by the way, you also set very strict effect sizes for Cohen's d of 0.4. Social personality, that's around 0.3 and whatnot. So those are also large effect sizes that you're finding. So when we look at something like retrieval practice has a Cohen's d of 0.7, but then retrieval practice with some space in between rather than mass retrieval practice, the Cohen's d jumps to 0.9. Once again, retrieval practice 0.7, but combined with high feedback, that jumps to 0.9. You've presented a lot of these really neat principles with these impressive effect sizes as sort of one-on-one manipulations. Do you know what happens when these combine? Do you have a sense, are these sort of additive? Yeah.
Boy, I think that is a great question. It's something we've been thinking a lot about in our lab, and we've tried, especially with generative learning strategies like retrieval practice that you're talking about. Would it be good to combine maybe retrieval practice with self-explanation? Would that like maximize it in some way? We haven't had a ton of success in finding additive effects. But I think we just maybe need a little more research. I think some of like our principles easily can combine because they're not really competing with each other in any way.
Yeah.
But some of the, more heavy-handed ones, we don't yet have evidence that combining them has some kind of additive or even multiplicative effect yet. But I think that's a research question we've thought about from time to time, and we've done a few studies on it, but I don't really have any great answers yet.
I can imagine it's difficult to pass out which one is doing the legwork and whatnot, but those are impressive effect sizes. Does anyone else have another question before I go on to my second question? Kaylee.
Sure. So I was trying to unmute myself in the right number of places. Can you hear me?
Yes.
Yeah, okay. So you talked about some of your results being a little bit surprising. You said in one case, for example, you had your grad student repeat it 5 times before you published it. I'm curious, I imagine you've done many more studies than you presented here today. Are there any things where you've expected something to work, but it didn't? So what sort of studies have you done where you didn't get an effect size that was passing your zero point 0.4 threshold?
Yeah, even that's a great question. I think if everybody publishes things that did work, it's almost impossible to publish things that don't work. And I think it's important to know what doesn't work. So even just going back to like that personalization principle, when my a student Roxana Moreno, discovered that, we tried to push it even further by mm, kind of being excessively polite in the wording and more self-revealing in the wording. And we found that too much of a good thing actually depresses learning. So there's kind of a happy medium. It's good to be conversational, but you don't want it to be too obvious. So, like in the lightning lesson, we we added things like, "Oh, you're standing outside and it's starting to rain. Boy, you're going to get wet now." That kind of turned out to be more of a seductive detail, I guess. That kind of depressed learning. So that's telling me, yeah, you can't be like too conversational or politeness, I kind of lump in with this, or too polite in your wording. It it kind of backfires. So that's just one example that comes to mind when you bring that up. But we've had plenty of failures, I'll tell you.
Thank you for sharing that.
Sure.
So I see you've spoken about some boundary effects, and there's a question from the chat saying that thank you for the wonderful talk. I'm wondering about the diversity of the learners in your studies.
Yeah. We've really, I mean, that's a great issue. We've started to try and look at that. We're working mainly with UCSB students who are not a very representative sample of learners in the world. It's impossible to get into this university, and so we're getting people who are already pretty good students, and then we're trying to figure out how to help them learn better when they already pretty much know how to learn better. Um, but we're still getting effects, so that makes me happy. Some of our studies have been done in real classrooms with real students, which I'm happy to see. Um, but we've looked at gender effects in some of our studies, uh, and some of our studies that involve different ethnicities of the instructor, we've looked at that as an issue. We haven't really gotten anything too consistent with that. But I would say that the issue that we're kind of trying to really get to right now is individual differences in executive function, because I think some students are very good at managing their attention, and that obviously helps them be successful students. But there are a lot of students who don't have great skill at managing their attention, on focusing in on the lesson. So we kind of want to look at how can we support learners who are more prone to being distracted. And this is particularly important if we're going to use something like virtual reality, because that is a very distracting environment. And video can be too if it's designed with a lot of production quality. Our work doesn't have good production quality, so it's not quite as distracting, maybe. Um, so we're looking at ways, how can we support um, people who kind of score lower on executive function, which we're viewing as attention control or ability to focus. And we're finding that, for example, learning in virtual reality is particularly difficult for people who score low in executive function. Learning from a PowerPoint lesson, it doesn't seem to affect them. So with a more distracting medium, executive function becomes a lot more important, and we need to figure out ways to help support people um, when they're put in these learning situations that could be potentially distracting. So that's kind of the issue that we've been obsessed with over the last couple of years. I'm hoping we're going to come up with some good answers to that.
That it got me thinking along the lines of like large numbers, at least in the Pacific Northwest here, students have accommodations for sort of neurodivergence. And some research by Dunlosky and Rawson and others have looked at retrieval practice within students with ADHD and sort of the impaired executive function. So I'd be interested to see whether some of these simple like pointing on where to focus or those coming up would be especially effective.
I
Um,
I think it would because I think a problem a lot of learners have is just knowing what to pay attention to and maintaining attention. So if we can kind of build in support in our lessons, but more, it would even be better to help them develop learning strategies so they can control it themselves, like through retrieval practice. That I think that is a really fruitful area of research. That it has a long history. It's not like we're rediscovering it, but when we're looking at learning with media, it kind of takes on a new importance.
that's right. So, sticking with these different groups, another question, another person asks, are there any noticeable differences in terms of age cohorts, so kids, younger adults, and seniors?
I think that's a really great question. We have focused mainly on young adults, so I feel most confident that these principles apply to young adults, um, and maybe could apply to adult training. Um, some of them we've tried with um, high school, middle school, and even elementary school. We don't have as many studies, but when we have tried these in those contexts, we've gotten the same level of effect. So I think they could apply, but we don't really have enough evidence to make comparisons across age groups yet.
If I may, now we have 3 minutes left. In the study where you spoke about the cold virus and using pictorial pictures with color and whatnot rather than just line graphs, you mentioned something interesting that it created a positive effect. And I was wondering, were you able to tease apart how much is it the effect around the learning, or is it the visual imagery that that picture is much more visually rich and I'm able to recall it much more easily? Are you able to pass out
That is a
processes?
really great question because yeah, we have been focusing on the idea that well, we kind of have this model called the cognitive affective model of e-learning, which is the idea that you view the lesson, it primes positive processing, um, and also a kind of social processing because you feel closer to the instructor, and that primes deeper cognitive processing. So it's kind of like a chain. But it very well could be, yeah, maybe just that imagery is more salient, and so you can remember it better. That's an entirely a legitimate explanation. So yeah, we have to tease those apart. We haven't done that yet with emotional design studies.
Thank you very much. I think there's one more question. Are most of your studies done in controlled lab situations or in course classrooms? Is learning measured through multiple choice or different outcome measures?
Yeah, you know, I live the world I live in, we focus mostly on lab studies because we can control things better. So the price you pay for that is asking, well, does it apply in the real world? But I've kind of felt when I started this, I just wanted to make sure these effects existed at least if in a very well controlled environment. So, okay, I'm pretty convinced that some of these actually exist, but we do need a lot of research on seeing how well they apply in classrooms. And in terms of dependent measures, to me, that's always the hardest part in doing research. You might think it's designing the lessons, but the harder part is evaluating how well do people understand it. Um, and so if you're trying to measure transfer or understanding, I mean, that's been going on for a long time. I think Bloom's taxonomy in 1956 was one of the first major attempts to focus on how can we measure something other than just retention. So what we do is to provide open-ended, short, focused, open-ended questions like, for the tire pump, how could you redesign the pump to be more effective? If you understand how it works, you might be able to come up with some solutions. Then our rubric is just a list of acceptable answers, and we just try to see which acceptable answers did they come up with, or it's not working, what could be wrong? And we have like a list of things that they should say, and we see which ones are those. So our our test of transfer is more these focused little essay questions that take a little more time to score, but and you need multiple raters to make sure you have inter-rater reliability, but I think they get at understanding better. We could have multiple choice questions. They're kind of harder to design, but it'd be certainly legitimate to have multiple choice questions.
Well, thank you very much. That takes us to 1:30, and this next bit would be a lot easier if we were in person. But since we are here digitally, we do have a token of our appreciation for you, in terms of an honorarium for sharing your time, your expertise, and being so generous today. And we will reach out to you afterwards to arrange getting that to you. So
Well, thank
thank
you.
you once again. And that then brings us to the end of our third biennial H5P conference. We started out with Dr. Veronica Yan talking about some of these cognitive principles behind learning and memory. We then went through several use case scenarios, innovative uses of H5P, and how people have been integrating H5P into their courses. We had a very rich panel discussion today, and then ending off with Professor Mayer's excellent keynote. That's given a number of actionable steps, changes that we can make not only in videos but in the classroom, and I'm sure it sparked a couple of ideas as to how H5P can help us achieve that as well. I would like to thank all of you for staying here to the end, for coming. This conference wouldn't be anything without you and your interest in H5P and the work that we do and the work that you do. So thank you very, very much for coming. And that formally brings us to the end of our 2-day symposium. Thank you very, very much. Oh, yes, someone said thank you, team. I would get the slides up, but I would very much like to thank Will Engel, Rie Namba, Manuel Diaz, Bo Sung, Kim, Kaylee Johnson, John Cheng, and Ross McCurlick, who would nothing would be possible without the seven of you in organizing this. So thank you very much, and maybe see you in 2 years. Hopefully see you before then. Thank you so much for coming.
And I just want to give also a special thanks to Simon and Kaylee, who have been doing a lot of the emceeing for this event, and are working faculty and researchers and instructors themselves. So appreciate the ability to work with them on behalf of the organizing committee. So
Thank you. All right, take care, everyone. Have a good day. Enjoy the rest of your reading break.